Hello, welcome to Petals for Your Troubles.
Pleasant day, everyone! We have prepared some questions about our pet fish that has got into an adventure. So the fish was swimming in a horizontal plane with an initial velocity of 4.0 I hat plus 1.0 j hat meter per second at a point in the ocean where the position relative to a certain rock is 10.0 I hat minus 4.0 j hat meter per second. After, our adventurous fish swam with a constant acceleration for a full 20 seconds with a velocity of 20.0 I hat minus 5 j hat. The challenging mission given to us is to solve the components of the acceleration. The second one, what is the direction of the acceleration with respect to the unit vector I hat? And the third one would be, if the fish maintains constant acceleration, where would it be when the time is 25 seconds and in what direction would it be moving? Some exciting clues that Mr. Fish has left us is that the initial velocity is 4.0 I hat plus 1.0 j hat meter per second, as the location stands in 10.0 I hat minus 4.0 j hat meters, with a constant acceleration for 20 seconds. The velocity is 20.0 I hat minus 5 j hat. So let's start conquering our mission. So in solving for the components of the acceleration, we'll use this formula. A is equals to final velocity minus the initial velocity divided by the time given. So we do the substitution, or we just put it all in. So 20 I hat minus 5 j hat meter per second minus 4 I hat plus 1 j hat meter per second divided by 20, which is your time. Doing the subtraction, it leads us to 16 I hat minus 6 j hat meter per second divided by 20. We divide this, meaning we separate them, break them down, leading them to 16 j hat meter per second squared divided by 20, subtract it to 6 j hat divided by 20 meter per second squared. The second formula given would be A is equals to AI I hat plus AJ j hat. Respectively, we'll have two answers, which is 0.8 meter per second squared, and the second would be negative 0.3 meter per second squared. This will result to two different answers. For letter B, we're going to be looking for the direction of the acceleration with respect to unit vector I hat. So in this, in order for us to look for the theta, we just put it in the calculator, which is tangent to the negative 1 times negative 0.3 divided by 0.8. It will lead you to negative 20.56. But because the angle cannot be a negative number, and it is relative to the x-axis, we have to subtract it from 360 degrees, which will lead you to 339 degrees from the x-axis. The formula that we will be using is the final replacement I hat will be equals to initial displacement I hat plus initial velocity I hat times t plus 1/2 a I hat t squared. We do the substitution method and put in all the numbers and the values that are required, which will lead us to 10 meters plus 4 meter per second times 25 second I hat plus 1/2 times 0.8 meter per second squared times 25 second squared. Doing the math, it will lead you to 360 meter I hat for the value of this number. In solving for the displacement for the j hat, we will use the same formula, however, the values will change because of the different numbers. It's going to be negative 4 m j hat plus 1 meter per second times 25 j hat plus 1/2 times negative 0.3 meter per second squared times 25 seconds squared. It will lead you to negative 72.75 meter j hat as your answer. Next, we'll be looking for the velocity for the I hat, which is initial velocity I hat plus a I hat times t. It will be equals to 4 meter per second I hat plus 0.8 meter per second squared times 25 second I hat. And the total answer will be 24 meter per second I hat. Lastly, when looking for the velocity of the j-hat, we will use this formula. It is equals to velocity j-hat plus a j-hat times t will be equals to 1 meter per second j-hat plus negative 3.0 meter per second squared times 25 seconds, which will lead to negative 6.5 meter per second. However, this is not the end. We have to look for the theta, which is the angle. So tangent to the point of negative 1 times negative 6.5 divided by 24 will be equals to negative 15.15, which will lead to 15 degrees as your answer.
Mission accomplished!
Thank you very much for watching our video, and we truly hope that you have learned something from it. Thank you once again, and have a pleasant day, everyone. Thank you!